Hello, in this lecture we're going to talk about ER model, ER diagram. So in designing a database schema, we have to make sure that we avoid these two major pitfalls. One is redundancy. So bad design may result in information being in two or more different places. So redundant representation of information may lead to inconsistency. So we have the same information in two different places, but the data is inconsistent. Incompleteness is another one. So bad design may make certain aspects of the enterprise difficult or impossible to model. Okay, so avoiding bad design is not enough. There needs to be a large number of good designs where we must choose. So we use this thing called entity relationship model. We call it short for ER model or ER diagram. So this model is an enterprise as a collection of entities. So entities are things or objects and relationships. Okay, so thing or object in an enterprise that this is distinguishable from other objects. Okay, relationships are, associations, relationships between usually two entities. Sometimes we could have relationship between two or more entities. Okay, so we use this ER diagram to represent this diagram. Okay, so on whole we have three different sets. We have the entity sets, relationship sets, and for each entity we have attributes, a list of attributes. Okay, so entity is a thing or an object. Entity set is a collection of similar entities. Okay, so it's similar to like a class. I know you guys took programming in an object-oriented language. Attributes are properties of certain entities. Okay, so this could be like simple values, it could be integers, it could be characters. You could also specify how many characters, how many digits of numbers, and so on. Okay, so we have certain shapes that we use. So for the entity set, we use a rectangle. Okay, and then relationship, I guess it's not on here, but relationships are represented using a diamond shape. And then attributes, we're going to be using ovals, and within the oval we have the name of the attributes, and the attributes are connected to the entity, which is a rectangle. Okay, so here is an example of an ER model. We can see here that we have two entity sets. We have one is called students and one is called courses, and there is one relationship that's connecting the students and the courses. Okay, and so students are enrolled in courses. So this is the name of the relationship that's connecting these two entity sets. Okay, and then here there you can see that there's M and N. Okay, so this has to do with cardinality. It's saying that it's a many-to-many relationship, meaning students may be enrolled in multiple courses. So this is anywhere from one to many numbers, and courses can be taken by multiple students, one to multiple students. That's why we have M here. Here we have attributes in oval shape. We have age, GPA, student ID, and name. And these ovals are connected to the student's entity sets, meaning these attributes are related to students. So the age is the age of the student, GPA, student ID, and name. And over here, over on the courses side, we have three attributes. We have credits, course ID, and course name. Okay, so these attributes are related to courses. And notice how we have CID that's underlined, and over here we have the student ID that's underlined. So this means that this is going to be the key attribute, meaning no two students will have the same SID. It's going to be unique. Okay, and here we see an attribute grade in a relationship. So you can have, it's rare, but you can have attributes for relationships. So this grade, it could be part of student, but then which grade, right? So this grade has to do with this particular student that has taken this course. That's why we have this in the relationship. So entity type, it's a group of collection of objects. Okay, we'll move on to some examples of entity types. So there's physical and conceptual. Most of these entity types will be physical. So things like student, faculty, property, customer, staff, product. These are physical beings, right? So these are the physical types of entity. We also have conceptual existence of entity types. So sale, which is it's not a physical, but it's sale is a type of entity. You also have viewing, inspection, work experience. Okay, so these are the conceptual type of entity. Here is an example, a very simple example. We have beers being an entity set, and this one has two attributes. One's called name and one's called manufacturer. Each beer's entities has values for these two attributes. Okay, so this is going to be the manufacturer as well as the name. So an entity set is a set of entities of the same type that they share the same properties. So here we have an instructor table that has three attributes, and ID is going to be the key for this table. We have course, which has course ID, title, credits. Course ID is unique. It's the key, so it's underlined. Okay, so these are called primary keys. Most tables, they all have some kind of a key, and make sure you underline those. Okay, we have an example of an instructor table, which has their instructor ID as well as their name, last name. Okay, here we have student table, which has their student ID as well as their last name. Okay, entity set can also be represented like this. Instead of using rectangles for the entity set and attributes as oval, you can actually do it like this. Okay, in a table form. So up here we have the name of the table. We have instructor, we have ID, name, salary. These are going to be the list of attributes, and then same thing, we have underlined the primary key being ID. Same thing with the student table. This is the name of the table, and then these are the list of attributes for the table student. Okay, so these are two different entity sets. Okay, relationships connect two or more, sometimes more than two entity sets. Okay, we use the diamond shape, as you saw. Okay, so here we have the student entity. The ID is 44,553, and this is their last name. We also have an instructor over here, okay, Einstein, and then the relationship here is connecting these two. Okay, and this relationship is called advisor. Okay, so this instructor is the advisor of this particular student. Okay, so here we have an example, same thing with instructor and student. So we define a relationship set advisor that we just saw, okay, to denote the associations between the students and the instructors who act as their advisor. So we can draw lines between these two entity sets for related entities. So here, Crick, Professor Crick is the advisor for Tanaka, this particular student. Okay, so we can use a diamond shape to represent the relationship between the entity set instructor and student. Okay, so this is kind of a bigger table example of ER diagram. We have bars entity set, beers, and then we have drinkers. Okay, and then between these three entity sets, we see that there are three different relationships. Okay, so this bars sells beers. Okay, bars and drinkers. So drinkers frequents certain bars, and drinkers likes certain beers, right? And we can see that there are attribute names, and notice how there's really no nothing underlined, right? So the key here is not denoted because name of a bar is not going to be always unique. Address or license. Address might be actually the key here. Okay, and manufacturer and name. Then so you could have more than two beers with the same name. So there's really no key here. Okay, An attribute can also be associated with a relationship. Okay, so here, this Professor Crick is advising the student Tanaka, and there is a date associated with it. So the date associated with could be the date that their advising relationship was established, maybe. Okay, so this date would be an attribute of this relationship. Okay, we have the relationship sells. So we might have a relationship like this where Joe's bar sells Bud. Joe's bar also sells Miller. Sue's bar sells Bud, Pete, so it sells 3 different beers. So here is what it would look like in an actual table, the database. Okay, so a lot of times these relationships will be binary, meaning as you saw here, this relationship is binary because it's connected to exactly 2 different entities, and usually that's the case. But sometimes you will have relationships between more than 2 entities that are not binary. Okay, so students work on a research project under the guidance of an instructor. So relationship project guidance or project guide is a ternary involving 3 different entities between instructor, student, and project. Okay, this is what we just talked about. This instructor is advising this student, and there's a date associated with it. Okay, we have bars sells beer, and then there is an attribute to this relationship, price, right? So this price is a function for both bars and the beer. It's not alone, right? This bar. So if we had price as an attribute of bars, it would not really be accurate or not really useful, because what is this price for? Because I'm sure each bar sells many different types of beers and they're all different price, right? So it's not really useful to have price here for bars or accurate. What if I have price in this beers entity set? Well, different bars for the same beer, I'm sure they have different pricing, right? So by having the price here in the relationship, it's saying that the price for this beer at this bar is a certain price. Okay, so this is the non-binary relationship involving the instructor, project, and students. Okay, so this is called a ternary relationship. Most of the time it is binary. Okay, so here we have bars, beers, and drinkers. Okay, so this drinker has a preference for bars and beers, right? So maybe they like to drink certain beers at bar A, but they like to drink another beer at bar B. So that's why this preference relationship is a ternary relationship involving all 3 entity sets. So here's a typical relationship set where Joe's bar, and then we have Anne. So Anne is a drinker. Anne likes to drink Miller at Joe's bar. Anne likes to drink Bud at Sue's bar. Anne likes to drink Pete's Ale at Sue's bar, and so on. Okay, and lastly, we have the attributes, which are properties of certain entities or relationship types. So we have staff that has these 1, 2, 3, 4, 5 different attributes. Staff number or staff ID, name, gender, position, and salary. And as you see here, staff number is underlined, meaning this is the primary key. No 2 rows of data or no 2 staff will have the same staff number. Okay, so this is called a primary key. Okay, attribute domain, this is a set of allowable values. So percentage, it should be a number between 0 and 100, right? You cannot really have 101% or a negative number, right? And date of birth must be for the current date, obviously, because you cannot be born in a future date. Okay. So most of these attributes are going to be simple attributes. They're atomic. It's just one number. Okay. So for example, social security number is a 9-digit number, right? So it's just a simple attribute. There's nothing else to it. In other cases, it could be a composite attributes. These are not really recommended, but sometimes they have attributes that have multiple components to it. So for example, someone's address, it has different parts, right? It has the street number, the name of the street, the name of the city, state, and the zip code. So this one has multiple components. So here is an example of a composite attribute. So the name, it has a first name, middle initial, or it could be middle name, and last name. So this name really has three parts. And like we talked about, address has street, city, state, and zip code. And street also has different parts where it has the street number, street name, and possibly an apartment number. Okay, so this is an example of a composite attributes. Okay? And this is how you would represent that in a table form. We have the name of the entity set here, instructor, their ID number. This is going to be a simple attribute. Name is Na. Okay? It has first name, middle initial, and last name, and address also has different parts. It has a phone number, date of birth, and age. Okay, so make sure you watch the video on Canvas. Okay, chapter reading, we're still on chapter 6, and the first homework is now released. You should be able to do these. So this is regarding the ER diagram. It's 6.12, it's in chapter 6, 6.24. This is from the textbook. So make sure you work on this and upload it before the due date on Canvas. So let's now move on to our first exercise. So usually I give an exercise and I give you guys some time. If this was an actual classroom, a physical classroom, you would be working on this in your classroom. So I know it's really tempting to just skip over the video and get to the answers, but it's really helpful if you actually try this on your own. Like actually try this before looking at the answer. Okay, so assume we have the following applications that models soccer teams, the games they play, and the players in each team. So in this design, we want to capture the following. So we have a set of teams. Each team has an ID. Okay, it has a team name, the main stadium that they like to play at, their home stadium, and to which city the team belongs to. Each team has many players. Each player belongs to exactly one team. Each player has a number, unique identifier. There's a name of the player, date of birth, the year they started, shirt number that they use. Teams play matches. In each match, there is a host team as well as a guest team. The match takes place in the stadium of the host team. And for each match, we need to keep track of the following. So the date on which the game is played, and the final result of the match. The players participated in the match. For each player, how many goals he scored, whether or not he took a yellow card, whether he took a red card. During the match, one player may substitute another player, and we want to capture this substitution and the time which this took place. So these are going to be all the different attributes. Each match has exactly 3 referees. For each referee, we have an ID, unique identifier, the name of the referee, their date of birth, how many years of experience, and one referee is the main, the other 2 are going to be the assistant referees. Okay, so all this information has to be shown in your ER diagram. So design an ER diagram to capture all these above requirements. Okay, state any assumptions that you might have that might affect your design. Make sure to use cardinalities. We have not covered this yet, so you can skip this part, but do make sure that you have underlined all the primary keys in the entity sets. Okay? So you will see something like this on the midterm. So this is a great opportunity for you to practice and try it on your own. So I'm going to give you guys about 10 minutes. Okay, let's go over it. Okay, so your answer might look different than this, and that's fine. There are multiple different versions of the right answers. So in this particular example, we have 5 different entities. So I'm guessing most of you have at least team, player as the entity sets, right? So we have team, player being entity sets, and then there's a match. Okay, and then we have match player and then referee. It's possible that maybe some of you made these to be a relationship or maybe an attribute. Okay, so for each match, we have a host team as well as a guest team. Okay, and then a player belongs to a team. So we have not gone over the cardinality information, but we'll just go over it. We'll cover that in the next lecture. So a player belongs to exactly one team. Okay, and then a team has multiple players. That's why we have arrow just on the one side. A match contains exactly one guest team and exactly one host team. So this just means one. Okay, player belongs to one team. Team has multiple players, so there is no arrow here. And then each match, there are 3 referees. So this is the role for each match. And then here, instead of having 1 or something, we are referring the range, the possible range. And that's 3.3. So this means that there could be exactly 3 referees. And then here is a match player. Okay, so a player, each match player has a player that plays in a particular match. Okay, so a player plays in a match player, and in match is a relationship between match and match player. Okay, and then we have sub. Okay, so I think here there was something about one player may substitute another player. We want to capture this and the time where this took place. So we have time being one of the attributes of this relationship. Okay, so team has the team ID. It's underlined because that's unique. Name of the team. So this is not a key because more than one team could have the same name, right? Possibly. And then we have the city and the stadium. Okay, here we have player, which player num is going to be the key, the name of the player. You could have more than one player with the same name, so that's not a key. Their date of birth, their shirt number, jersey number, and the year that they started playing. Okay, and then the match has the date that it took place, the date the match took place, the score of the host team, and the score of the guest team. Okay, and then here we have referee. Each referee has a date of birth, their ID, which is unique, it's primary key, their years of experience, and the name of the referee. And there's going to be exactly 3 referees, and for each referee in a match, one is going to be a main. So this will be like a boolean. So it's either true or false. If they're the main referee, it's true. If they're the assistant referee, it'll be false, right? And then what else? So this match player has the number of goals that this player scored in a particular match. The ID, if they got any red flags in this match, if this player got any yellow flags in this match. So these are going to be maybe like a number. So depending on how many they got, it'll be like a number integer. Okay, so here is an example. Yours might look different. If you want me to take a look at your EO diagram, you can always message me, or you can message me on Slack or email it to me. Okay, that's it for this lecture.